Good afternoon. For those of you that haven't joined us before, my name is Mark Stewart and I'm a director of RSK's Geosciences business. And I'd like to welcome you all to the latest in our Down to Earth webinar, which today is being given by my colleague Sarah Cook from Leap Environmental, who's going to give us a presentation on Leap's innovative Foundations Carbon Calculator. But before we get into that, I'll just run through some housekeeping. So all of your microphones are on mute, so we can't hear you. During the presentation, you can post any questions that you'd like to ask, and we'll do a Q&A session at the end. We'll answer as many questions as possible. If we can't answer your questions, we'll try and get back to you individually. Just bear in mind, this isn't a talk about geotechnics, it's about carbon. Shortly after the webinar, you'll receive a link to a short survey. If you could take a few minutes to provide us with some feedback so we can improve on future webinars, that would be very gratefully received. So without further ado, I'll introduce Sarah Cook, who's going to be presenting to us today. Sarah is a chartered geologist, and she's also a registered ground engineering professional with 18 years industry experience in geotechnical and environmental sector. She's an interest in sustainability and low carbon solutions, which was inspired by her recent studies during the completion of an environmental law masters. So without further ado, I'll hand over to Sarah.
Thanks, Mark, for the introduction. I'm now going to turn my webcam off for the duration of the webinar. I'll see you at the end. So, quick overview of what I'm going to talk us through today. I'm going to talk to you why we, like many others, have started looking at sustainability and carbon reduction. I'm going to introduce you to our carbon calculator. We've developed the carbon calculator. It's over 6 months collaboration project with the University of Surrey to assist our clients with their move to net zero. And then once I've shown you our carbon calculator, I'm going to talk you through a case study of a site in Hampshire that we've been using as a test site throughout our development, as I always feel it's easier to see something in practice, and gives you a context of the savings that it's possible to make immediately on your sites to reduce carbon emissions. So just a quick reminder for anyone that has looked at carbon for, anyone new to carbon emissions. Embodied carbon is the carbon dioxide emissions associated with the materials and construction processes throughout the whole life cycle of a building or infrastructure. Includes any carbon created during the manufacturing of the building's materials, so that materials extraction, transport to manufacturing, and then the movement of those to the construction site and the construction practices themselves. Put simply, embodied carbon is the footprint of a building before it becomes operational. It also refers to the emissions produced maintaining the building and eventually demolishing it, transporting the waste away and recycling it. Operational carbon is the carbon that comes from the energy, the heat, the lighting, and anything else used in the operations. Following advances in reducing the operational carbon, recent data from the World Green Building Council has indicated that the embodied carbon is now becoming a larger proportion of the building's overall carbon footprint. So while I'll use the term carbon throughout this presentation, we're looking at carbon dioxide equivalent, and this actually accounts for carbon dioxide and all the other gases as well, greenhouse gases, methane, nitrous oxide, etc. So what's the problem and why are we looking at it? Well, unless you've been avoiding social media for the last couple of years or spending all your time looking at the other big C of COVID, then it's difficult to have missed the conversations that we've been having on climate change. And COP26 has definitely brought the climate conversation into the mainstream media. This graph is outlining the global emissions and the steady rise of global carbon emissions, accelerating in the last 3 decades, despite our growing awareness in this time. We've had the Earth Summit in Rio in '92, the Kyoto Protocol in '97 set an original target to reduce greenhouse gases, including carbon dioxide, by 5% on 1990 base levels. And then subsequently, we've had the Paris Agreement in 2016, which, rather than moving on percentages, looked to set a target on greenhouse gases to keep rising global temperatures below 2 degrees and 1.5 degrees where possible. Despite this, and despite all of these agreements and protocols, it's kept going up. The graph keeps going up. Climate Change Act in the UK is clear. The UK has got to end its contribution to climate change by 2050. And UK emissions are dropping. We are meeting our 5-year rolling carbon budget. But so far it's been easy wins, such as the move from coal to renewable energies. And there's much slower movement in the built environment sector, sadly. As you can see from my graph, in order to cut emissions to zero by 2050, there's going to be some fairly ambitious changes that need to take place. And the legal requirement for net zero means those of us that are not decarbonised are likely to have a reduced value long before 2050. More people are becoming more focused on better ESG credentials, and I guess it's in everyone's best interest to deliver low carbon options to provide longer term valuation resilience to your companies. So going into a bit more detail for us in the construction industry, buildings are currently responsible for about 39% of global energy related carbon emissions, 28% from operational emissions, and that remaining 11% from materials and construction. And drilling down further into that, cement and concrete is responsible for 8% of emissions. That's talking about carbon emissions, and on the other side, in 2016, the construction and demolition industry accounted for 63% of the waste produced in the UK. Majority of this is recycled. Approximately 5 million tonnes are still sent to landfill. So alongside our net zero move by 2050, there's also a move for zero avoidable waste for 2050. The accompanying construction and demo waste stream needs to move to a circular economy, which focuses on minimum input and minimum output, rather than the linear economy we currently work on, which has use and bin, basically. While we're looking at talking about carbon today, it's worth remembering that the less materials we use, the better use of natural resources we're able to maintain, and the less waste we'll produce. So, well, what can we do in the built environment? Put simply, we just need to use less stuff. So how can we achieve that? Well, we could build nothing, which would result in 100% reduction in carbon, but as I quite like my job, I'm not going to be suggesting that as an idea going forward. We could look to build less. So we could look at using existing assets, existing foundations, for example. But the best that we can support in our current role is to build clever and build efficiently, using low carbon materials. And this is where our carbon calculator will help in the minimising of resource consumption and helping to eliminate waste. So you can reduce carbon at any point in the delivery process, but the earlier you think about it, the greater the opportunities are. And that's why we feel we're in a position with our early involvement in sites for maximising the opportunity in the design and construction process for the reduction of carbon emissions. So, excuse me, so to talk to you about our calculator itself. In response to the climate crisis, we think that the first instance, the response needs to be targeted towards what we can currently do, existing technology and available data, rather than relying on technological advances that may not help us, and to coin a Boris phrase, flatten the curve and get that graph I showed you pointing towards zero. So as I've just mentioned, leaps on site at the beginning of a process often even prior to purchase of a site, and as such we're in a unique position to be able to assist or influence the design of the site, help improve the carbon efficiencies of the site's foundations. We were set a task 2 years ago to look at improving our sustainability, and it was recognised that we could all use recycled pencils or drive an electric van to site, but actually the most important thing we can impact is how much soil is dug out of the ground, be it for the foundations or for remediation reasons. And with foundations, the amount of soil coming out directly impacts the amount of materials going in, so it'll have an impact on the excavated soil reuse too. And just to remind the calculator, our calculator is looking at upfront embodied carbon emissions. It's not carrying out a whole life cycle assessment. So our calculator is a series of many Excel spreadsheets, which lead us through the addition of a significant volume of site-specific data. Most of this is available, and where we're able to, we can gather it as part of our site investigation works. The most important bits of information at the start, we need the site area or built area and the geology. Ground model is simplified to similar to that which you might give you for a piled foundation model, with options for high PI, low PI clays, sands, chalk, etc. There's also ability to input thickness of made ground, which comes through as part of the calculation. It's useful for calculating waste. So assumptions on things we can change in our model. Well, we can look at the size of the house, otherwise we default to the BRE standard size, and we know the number of those across the site, detached, terraced and apartment blocks. We can input the unit wall designs as a simple box or with internal walls, and then we move on to foundation information. The diagrams above indicate the information inputted for this, the most important being the depth to formation level and the foundation width for strip foundations. And for the piled foundations, it's the diameter and pile length is the most important. Other extra information is always great. The percentage of steel reinforcement can also be included. And where it's not available, it can default, and it's something that we can modify throughout the design process. The final information that's included is for waste. This takes a ground model, so it takes topsoil, made ground and natural soils, and can be recorded the percentage of reused on-site, percentage used off-site and percentage that goes to landfill. The landfill option can also select between hazardous and non-hazardous. So we've put in a large volume of information, and out churns at the other end. We get an output that looks like the graph on the left. It gives the results for strip foundation versus piled foundation solution and compares the carbon emissions from both types of foundations, the materials used, the earthworks needed on site, the emissions from transport, site activity and the waste. And so you can quickly see that the more information available, the more accurate the output. You'll note there's a lack of numbers presented on my graph here. The calculator outputs the results as tonnes of carbon dioxide equivalent emissions. However, for a low-level site overview, we've made a number of assumptions and therefore a comparison of the relative results instead of an absolute. These numbers are available for more detailed modelling. We've decided, and as we've said, we think this is fairly important, that this information should be available to make an informed decision, and so we will be presenting this within our main phase 2 site investigation reports going forward. Further, more detailed calculations can be included with our standalone report. So I'm going to show you how this sort of applies to a site. I think it's always easier to see something in action. This is a proposed development of a site for 450 units. And it's a site I've picked because I know the geology well, having worked on it for 7 years. And the site developers have committed to reduce the emissions from its supply chain and customer homes by 24% by 2030. This value has been approved by the Science Based Targets Initiative and is consistent with restricting climate change to 1.5%. They agree with my earlier statement that at the moment, the more you reduce operational carbon, the more embodied carbon dominates. So we've carried out extensive pre and post demolition investigations with a total of 115 trial holes between 1 and 25 metres across the site. Site's a former barracks and has complex site history with many multiple development layers. It's underlain by the Windlesham Formation. It comprises interbedded sands and high plasticity clay across the majority of the site. Camberley sands outcrop in the northern corner of the site, which comprise medium dense to dense sands. So our foundation recommendations are a bearing capacity of 80 kPa, founding on the firm clays or medium dense sands below a metre. Piled foundations were recommended where there were 3+ storey apartment buildings or where there were any areas of deep made ground on the site. So we made a number of assumptions in putting this into our model. There's the geology model. So topsoil where present on site is 0.3 metres deep. Average the made ground across the site to 1 metre, and then taken the clays and interbedded sand and clays between 2 and 6 metres. We've made a number of assumptions, and this are fairly accurate ones because we know the depth of the piles next door. So we were able to include a 15 metre deep, 0.4 metre pile for the model, 0.5 metre thick piling mat, and for the model, I've also at this stage modelled the 450 houses at 1.5 metres deep and 0.6 metres wide. We've made the assumptions for the waste stream and soil reuse as per our recommendations and our remediation method statement. So on this site, we've assumed full reuse of the topsoil, reuse of 75% of the made ground, and 25% disposed of off-site to landfill, and the reuse of all natural soils on site as part of their cut and fill exercise. So here's the results. The results of the carbon calculator for this site indicate that the use of the 1.5 metre deep strip foundations compared to piled foundations across the site save approximately 1/3 of carbon emissions for the foundations. As you can see from the graph, the majority of the carbon emissions are from the material used for the foundation and for the earthworks. The calculator produces additional graphs where needed for further detail. So I've shown the one for earthworks here. And as you can see, strip foundations have considerably higher emissions, as you'd expect, than a piled foundation. But these emissions are still low in comparison to the material emissions and therefore doesn't have a significant impact on the overall carbon saving. The calculator also calculates a tipping point, or I've called it, until someone suggests something better, the magic number, where piled foundations are more beneficial than strip foundations across the site based on carbon emissions. On this site, for this geological model and the foundations we've used, this point is 1.8 metres. So we can go one step further on this site. This might not always be available. We might not be able to do this sort of pre-planning and design phase, but this could come out later on. We've got a foundation plan. So just quickly, the greens for a 1.5 metre foundations, working through 1.75, yellow in 2, red in 2.5, and some piled foundations, mostly in the apartment blocks. And we know that 1.8 on this site is that tipping point where it would be beneficial to pile for carbon savings. So we can have a look in a bit more detail at this site. So the first bar on this chart shows the total carbon for the foundations on the site. That's for taking the 190 approximately 1.5 metre deep foundations through all of the other foundations and the piled foundations, and that gives you the carbon total for the site. So there's no plans to do it here, but I've then compared it to what would happen if you piled all of the site, where, as you can see, so it's got a worse carbon outcome. Might not have been quite as bad as you'd anticipate, and that's partly due to the size of the site. And then I've modelled the site with changing to piling on the tipping point of 1.8 metres. This gives you an approximate 20% carbon saving on our current carbon totals. The reason why on this site that 20% isn't bigger is because there's quite a large number of foundations already at 1.5 metres, so it doesn't appear as a large saving as we have done when we've modelled other sites. And the last chart is with a change from current carbon totals to refined SI. And as I said at the beginning, we've done 115 trial pits across this site. So on this one, there's limited further improvement. However, I know from a model I've run on a neighbouring site, the further SI improved our recommendation for piling from 50% of the 240 plots to approximately 20%, and therefore brought a carbon saving of approximately 40%. So to recap what we've done, we have to make some ambitious changes to reach net zero by 2050. Our carbon calculator can help give that carbon cost for a site development. And the more information we're supplied, the more accurate we can make that calculation. The most effective solution may not always be the most cost-effective solution, may not always be the most sustainable. However, we can see that a reduction in material use should hopefully lead to a reduction in costs. And with less input and less output, supports the move to a circular economy. So finally, we are currently working on the next research project with the University of Surrey. This time we're developing a carbon calculator to work on remediation projects. It's currently being tested working on remediating landfill, and hopefully we'll be able to incorporate both into future projects. But I've asked a couple of questions there. And what should we look at next? So if anyone has any contributions where they'd like to see some carbon calculators, I'd be more than happy to have a chat about this. And thank you for listening.
Thank you, Sarah. It's very interesting. Hopefully this tool will be available to geoscience clients in the very near future, but we'll crack on with some Q&A. A few questions come in. We'll start with, could foundations be reused instead, and what the impacts of that?
So the short answer is yes, but realistically, I'm not sure. Like if we go back to our case study, obviously the last round of development in the 1960s, I'm not sure anyone would be willing to commit to building upon the foundations that were there prior to demolition. But I certainly think it's something that needs to be looked at moving forward. There is research going on into that, and that obviously then, if it's something that's thought about now while we're putting our current foundations into the ground, potentially, especially with piled solution, it might make that life cycle more appropriate, to look at piling rather than just strip foundations.
Okay. Are there other ground improvement techniques that could be used instead of piling with benefits in a reduction of emissions? Yes, so
we've started looking into this briefly, and that's another area of further examination. Yes, basically, I've forgotten the name of them now. mind blank. But yes, it looks about 10% for shallow ground like improvement works on site looks to have a significant saving on a piled solution. So that is definitely an alternative option if it's the grounds aren't suitable for shallow foundations, sort of vibro column piles. That's what I was thinking of. Yeah, it looks to be about 10% of the piled solution.
Right. Okay. As the government don't include air, sea, freight emissions and imported goods, should we be working on more truthful emissions data to include these?
Yes. That's a sort of a debate question, really, isn't it? But yeah, I think
how far do you take the tool?
You know, I know a lot about the built environment, and I don't feel that we've, you know, I think it's very industry led at the moment because there isn't enough regulation really being pushed through fast enough. Yeah. And therefore I'm sure it applies to all other sectors as well. And I think aviation will come eventually.
Yeah. If materials are greater impact than transport on emissions, where can we find the embodied emissions data on materials to specify ones with lower embodied energy emissions?
Yes, well, I didn't mention it, but we have our model, we have picked a typical cement option, and we can default for various different cement mixes, and so that data is all available via basically the Institute of Structural Engineers.
Yeah, okay. We've had one question come in, says is the tool available or is it private? And it is a commercial tool that we use with our clients, so it is something that we charge for. But so if anyone's interested in knowing how much, then they can get in touch with us, either myself or Sarah directly. Going on, where did you get your A1-3 carbon factors from? Did you use generic databases? Did you just answer that question?
Yes, yeah, we've I would have to defer that question back to our collaborators at University of Surrey, but I'm happy to email over.
Okay.
If I go into the back and depths of our spreadsheet, I can tell you exactly where they've come from.
Okay, we can get back to James. That was. Do you know whether using strip foundations is, in this case, also had a cost saving? Whether any carbon benefit analysis carried out?
What, on the case study site?
Yes, I guess it's meaning the case study. Yes. Yeah.
We haven't.
Was it cheaper?
I think isn't it always, I would say, preferred option until you get to a certain depth to go for strip foundations being cheaper. So yes, I anticipate it was. We haven't done a cost benefit analysis with them, and that would be quite an interesting thing to do.
Michael, I got your question. I'll answer that later. Tom, are there different pile types within the tool, and does it consider low carbon options available?
So yes, as I said, we've set it for a standard cement option, but we can default through the different low carbon options, and if the data is available, we can just add in as new technologies, or someone comes up with a new idea, that can be added onto it very easily.
And can you is there a standard or guidance for calculating embodied carbon?
Is there what, sorry?
Is there a standard or guidance for calculating embodied carbon?
I'm not sure on that one.
No. No, there's no standard. There's no standard for how you calculate embodied carbon.
We've sort of, used information that's sort of standard available for us to calculate it, and numbers, published numbers. So there is data available out there, yes.
Okay. Right, and that's all the questions we've had in. I've just had one of my colleagues point out to me that RSK Geosciences is currently working on a commission for the NHBC to assess climate change impacts on foundations and consider low carbon options. And I believe that report will be due for publication later in 2022. So thank you, Sarah. It's been really interesting. We've had about 120 of you online today. So thank you all for attending. Our next webinar will be on the 10th of May, and we'll be joined by another RSK group company that we've been working closely with, Carbon Zero Consulting, for a similar sort of talk. This will be a presentation on ground source heat this time, so something that we've all been getting more interested in. I hope you can join us again. Thank you again, and enjoy the rest of your day.
Thank you.